Problem 2. Find the derivative of g of t equals 2 over t plus t to the 5th power times the quantity t cubed plus 1. First of all, we're going to rewrite this like this. 2 to the times t to the negative 1 plus t to the 5th times t cubed plus 1, so that we can easily use the power rule. We see that it's going to require a product rule because we have a function times a function, or an expression times an expression. So let's set that up. First of all, let's lay out the framework for the power rule. And so we can say that g prime of t will equal, according to the power rule, 2t to the negative 1 plus t to the 5 prime times t cubed plus 1 plus t cubed plus 1 prime times 2t to the negative 1 plus t to the 5th. And now we're ready to actually take the derivative there. We've just laid out the framework for this. Now let's get ready to take the derivative. So, moving that up a little bit, we can now actually take the derivative here. And so we're going to get g prime of t equals. The derivative of the first expression, using the power rule, is a negative 2t to the negative 2 plus 5t to the 4th times t cubed plus 1. That's the first part. We will add to that the derivative here, which is 3t squared plus 0, because the derivative of 1 is 0, times 2t to the negative 1 plus t to the 5th. And that is the derivative. Now it needs to be simplified and cleaned up a little bit, but that's our derivative. So the simplification is all algebra here, and we can do a few things to make it a little easier to work with. We might start by rewriting the negative exponents as positive exponents. That's one small thing we can do. But you noticed I haven't actually multiplied these two expressions together. I'm going to go ahead and leave them apart, and then 3t squared. Again, I'm not going to distribute this through, so it becomes 2 over t plus t to the 5th. That is a very workable form of the problem. If we needed to do more, for instance, if we needed to take a second derivative, we might actually FOIL this out. But for our purposes, we're going to leave it there.